Hey guys, today I'm going to talk to you about multiplying binomials. Okay, remember binomials has two terms, which means like x plus 4. There's two terms there. Okay, so we're going to be multiplying binomials times binomials. Okay, these methods work for that type of polynomial. Okay, alright, so we're going to go through three different methods. Okay, so the three different methods we're going to be doing is the distributive property, using a table, and the FOIL method. Okay, we're going to look at each of these individually and go from each one. So in your notes, I should see a heading for one, then your notes. A heading for the next one, then your notes. A heading for the third one, then your notes. Okay, alright, so we are going to be doing the distributive property first. Okay, so with the distributive property, okay, listen carefully to how this works. I tried to put it in words the best I can, but it's kind of hard to explain. So you're going to distribute each term in the first binomial to the second binomial. So how that works is you are going to take this and put it here. You're going to put this here, okay? You're going to distribute it, each one, to the second binomial. Okay, so you separate the first one, put it outside, and then you just repeat the second one within. Okay, alright, so now we are going to do like you've been doing and distribute to each term. Okay, so what that will look like is x distributed to 6x, x distributed to 3. So you get 6x squared plus 3x. Okay, then go to the next one and distribute. 4 times 6x gives me 24x. Okay, and then distribute here, plus 12. Okay, so you're going to distribute to each term. Then you're going to combine your like terms. Okay, so we don't have any other x squared, so we can bring it down. 3x and 24x are our like terms, so we can combine those. And then 12 is by itself, so it is done. Okay, and combine like terms, you might hear that as simplify, same thing. Okay, so that is as far as you can go, and you have just multiplied a binomial times a binomial, giving us a trinomial. Okay, alright, so on your own, I would like for you to try 2x plus 2 times x minus 1. Go ahead and pause your video as you work it. I'm going to give you the answer here in just a second. Okay, so if you've worked it, you should have 2x squared plus 2x minus 2x minus 2. So these cancel out, so you have 2x squared minus 2 would be your answer for that one. Okay, alright. I didn't show all the work. Hopefully you showed all of your work. So that is the first method, which is the distributive property. Alright, so let's go to using a table. Okay, you're going to make yourself a 9 square when you have a binomial times a binomial. This first square will not be used. Okay, how this goes is you put x here, put minus 4 here. So you should see x minus 4. So there's your thing. Okay, on the other side you would put your first term, and then your second one you would put your second term. How this works is where your boxes meet, that's what goes there. So 3x times x gives me 3x squared. 3x times negative 4 gives me negative 12x. X times 2 gives me 2x. 2 times negative 4 is negative 8. Okay, so what I do then is go to standard form, which is your biggest one first. So 3x squared minus 12x plus 2x minus 8. Okay, then you're going to simplify just like we did. 3x squared minus 10x minus 8, and that's as far as you can go. Okay, alright, so I have one for you to try on your own as well. Okay, remember you want to make yourself a 9 box. First square is not going to be used. Okay, if this happened to be a binomial times a trinomial, which would be like something like this, then you would, that's minus 5, you would add another box here. But since it's just a binomial times a binomial, a 9 box is plenty. Okay, so setting it up is the hard part. Okay, so then we get 10x, we get negative 5x, we get negative 10x, or this should be 10x squared, sorry, and then 5. Putting it together, 10x squared. I'm going to go ahead and combine these, gives me negative 15x plus 5. Okay, so that is the table method. Alright, last one, and my favorite, is called the FOIL method, which stands for first, outer, inner, last. So what that means is, I'm going to use a different color for each one. So first, let's start there. First means the first term, you multiply the first term in each by each other. So you do 2x times x, which would give me 2x squared. Okay, then you do the outer. I'm going to change colors for you. Your outer, which means the outermost. So x times negative 1, which is negative x. Okay, I'm going to change colors again. Alright, so outer is outermost. First is the first in each binomial. And then we go to your inner. Your inner are the innermost. So innermost terms. So you do 7 times 2x, gives me 14x. Okay. And again, switching. And then your last. Your last is your last one in each term. So last in each, or second. Okay, so you get 7 times negative 1. Leaves me negative 7. Okay, so combine it all together. I can go ahead and simplify if I need to. So 14x and minus x gives me 13x minus 7. Okay, and we have now multiplied that. Okay, so you also have one other example for you to work on your own using the FOIL method. So remember, first, you're going to multiply these two. Just change colors. Outer, you're going to do the outsides. Okay? All multiplying. Inner, the inner two. And then your last is your last in each. Okay? So you should set up 4 different problems, combine it all, and then make sure you go all the way down simplified as far as you can. So with this one, I should end up with negative 6x squared. And then my outer would be plus 6x. My inner would be plus 12x. And then my last would be minus 12. Okay, if I combined negative 6x squared plus 18x minus 12, and that's as far as you can go. Alright, so that is how you multiply binomials. We will apply this more tomorrow. Okay, if you have any questions, come to me. Remember, your homework is the front side of, I think it's 8.2 or 8.3. I don't have it sitting in front of me. I think it's 8.3. The front side and all the questions, please. Okay, this will be a grade, I promise. Okay, so hope you have a good evening. Thank you.